Converting between logarithmic and exponential notation. So we know that f of x as an exponential function has an inverse function that we call log with the same base of x. One of the properties that we have learned about inverse functions is that if we composite them together, they very nicely unwrap one another and we get x back. So that gives us the log base a of a to the x power. We've composited them, we're going to end up with just x. Similarly, a to the log base a of x is again going to unwrap them and we will get x back. Now, this tells us that we actually are going to run into this property, that if we have y equals a to the x power, we can convert back and forth between exponential form and logarithmic form to get log base a of y is equal to x. Let's do an example. If I say that 25 is equal to 5 to the second power, we all understand that, that's no problem. However, if I match up the 25 with the y, the a with the 5, and the x with the 2, we can contort this around and turn this into 2 is equal to log base 5 of 25. And there's our conversion. I know this looks a little weird, but we're going to practice a few more. Let's start with 1/8 equals 2 to the negative third power. Well, again, y up here is going to be 1/8 in this case. A is 2, x is negative 3. So when we turn it all around, we're going to get negative 3 is equal to log base 2 of 1/8. Let's try another. We'll make this one a little weirder. So I'll say pi raised to the 7th power is equal to the letter m. Notice the y in this case is on the right-hand side. The base a is pi, and the exponent is 7. We're not going to be fooled though. We're going to contort this around. This becomes 7 is equal to log base pi of m. Let's go the other way now. Let's say we're given something in logarithmic form. Log base 2 of 1 over 16 is equal to negative 4. Well, we'll just be going backwards from our rule up here. And as we undo all of this, we will get that 1/16 is equal to 2 raised to the negative 4th power. Let's do another one and actually solve an equation. By the way, the base of a log must be positive. So let's begin our example. Log base x of 25 is equal to 2. No problem. We'll turn this around and we will get 25 is equal to x squared. Now we have a nice equation we can solve. I can do the square root to both sides. Normally I would do plus or minus, but because of our rule over here that our base has to be positive, x over here has to be positive, we're going to end up with x is equal to positive 5. Let's try another. Log base 4 of x minus 2 is equal to 2. We're going to convert this. Notice the base in this case is 4. I'm going to end up with x minus 2 is equal to 4 raised to the second power. X minus 2 is equal to 16, which means x is equal to 18. Last example. Log of x plus 2 over x is going to equal 2. When the logarithm has no base written, this means the base is 10. This is referred to as the common log. So if you'll notice here, we have no base, which implies that the base is 10. So, turning this around, we end up with x plus 2 over x equals 10 to the second power. If I multiply through by the LCD in this case, which is x, I get x plus 2 is equal to 100 times x. The 100 comes from the 10 squared, and the x gets multiplied here. I can now subtract the x to gather my like terms. This gives me 99x, which is equal to 2, and now I'm going to solve for x by dividing by 99. And there you have it.